Hello students, I am Purwar and today I am going to discuss about the vibration of normal mode when the string is fixed at one end and open at the other end. Okay, yeah. So let's start. Okay, let's say this is a string and it is fixed at one end. It is fixed at this end. Okay, and it is open at this end. At this end, it is open. Okay. Now, if string is fixed at one end and open at the other end, then at the fixed end, we know that node will be formed, and at the open end, anti-node will be formed. This we know, right? Great. Now, if we want the minimum possible frequency in which the standing wave will be formed, what provided the condition that at one end node should be formed, at the other end anti-node should be formed. So what shape can a string wave take? If here it is a node, then and here it is an anti-node, and we know that at the node point amplitude is 0. So amplitude means ax is equal to 0, and at the anti-node point, this point is node. That's why here the amplitude is 0. This point is anti-node. That's why at anti-node point the amplitude is maximum, and in the standing wave the maximum amplitude is 2a, so basically plus minus 2a. Okay, so this is the shape of a standing wave when it is vibrating in a fundamental frequency, in a minimum possible frequency. What is the meaning of fundamental frequency? Minimum possible frequency in which a standing wave will be formed, provided the condition at one end node should be formed, at the other end anti-node should be formed. Great. Now I am taking the length of this string is L. Great. Let's take the length of this string is L. And we also know that the distance between node point and anti-node point is lambda by 4. So this L can be written as lambda by 4. So this lambda can be written as 4L, right? Let's take this equation 1. Now we know that V is equal to F into lambda. Okay. So F is equal to V upon lambda. So again we know that the velocity of the wave on the string is T upon mu, where T is the tensor and mu is the linear mass density. Great. So F will be equal to 1 upon lambda root T upon mu. So from the equation 1, I can write in place of lambda, I can write 4L, and that will be equal to root T upon mu, right? Okay, I am calling this equation second, and I am writing it with a different color. Okay, now so this, if the string wave or standing wave on the string is vibrating with this frequency, then we say this the fundamental frequency, because this is the minimum possible frequency. Fundamental frequency. Why it is fundamental frequency? Because this is the minimum possible frequency with which a standing wave will be formed on the string if one end of the string is fixed and the other end of the string is open. Okay, great. Or also we call this the fundamental mode, fundamental mode, or we call this first harmonic. Okay, what do we call this? First harmonic. Okay, you will understand why I am calling this first harmonic. Just let me do some more analysis. Now I have increased the frequency. I have increased the frequency. So now the standing wave is vibrating with the increased frequency. So now what shape will it take? Let's see. Again, the condition is same. What is the condition? That the string is fixed at one end and open as the other end. Means at this end node should be formed, and at this end anti-node should be formed. So when this will happen, if I have increased the frequency, then obviously some more loop will be there. So now the shape of the standing wave will be like this. So here, in the previous case, in the case of fundamental mode, one node and one antinode was present, but in this case, two node and one antinode is present. One node is this and one antinode is this, and here one more node will be present, because here also the amplitude is zero. Here also the amplitude is zero. Ax is equal to zero. Here also the amplitude is zero, means As is equal to zero. Right? Again, the length of the string is same. I haven't changed the length. I haven't changed even the string. That's why the length will be same. The linear mass density will be same, and again the tension will also be great. So we can write L is equal to, we know the length between two node points is lambda by 2, and the distance between one node point and one antinode is lambda by 4. So L will be equal to lambda by 2 plus lambda by 4. That will come out to be 3 lambda by 4. So we can write lambda is equal to 4L by 3. Right? Right. Now again, from the equation of velocity and frequency, we can write F is equal to B upon lambda. Again, 1 upon lambda is equal to root T upon mu. We can write the value of lambda here. So it will give us 3 upon 4L root T upon mu. Okay. Okay, great. I am calling this equation second. Okay. Now let's do one more analysis. Then I will tell you which frequency I will call the first harmonic, which frequency I will call the third harmonic, which frequency I will call the fifth harmonic, and which frequency I will call the first overtone, second overtone, and third. Wait for a minute. Just let me do one more analysis, and then we will observe the pattern of this frequency. Okay. Now I have even further increased the frequency of the source. Now again, I want the string wave to be formed. I want the standing wave on the string to be formed, and the condition is same, that at one end node should be present, at the other end antinode should be present. So now let's form the, again the length is same, the length of the string is same, the string is same, so the linear mass density is also the same. Great. So now this is the shape the string will take. Okay, this will be the shape the string will take. So here again, at the end point, it is given that at the end point, at one end point node will be present, and at the other end point antinode will be present. But in this shape, two more nodes will be present. There is one node this and another node is this. Great. Again, the length of the string is same, so length is L. So I can write L is equal to, again the distance between two node point is lambda by 2 and lambda by 2 and lambda by 4. So what we can write? I can write lambda by 2 plus lambda by 2 plus lambda by 4. So it will give me lambda plus lambda by 4. That will give me 5 lambda by 4. Okay. Okay. Now again, V is equal to F lambda. So F is equal to V upon lambda. So 1 upon lambda is equal to root T upon mu. So I can put the value of lambda. So I will get F is equal to, sorry. Yes. Sorry. 1 minute. Yes. It is fine, but I just want the value of lambda to put it in this equation. So if we know L is equal to 5 lambda upon 4, then lambda will be is equal to 4L by 5. Okay. So now put the value of lambda in this equation. So it will be 1 upon, and the value of lambda is 4L by 5, and it is root T upon. Great. So F will be is equal to, I will take this above, so it will be 5 upon 4L root T upon. Great. Now let's observe the pattern. I am calling this equation third. This was the equation second, and this was the equation first. Okay. So now let's write all three equations here. First equation was S is equal to 1 upon 4L root T upon mu. This was the first equation. And second equation was 3 upon 4L root T upon mu. This was the equation second. Third equation was 5 upon 4L root T upon mu. Right? Right. Now, this is the third equation. Observe the pattern. This part, this term in all three equations is same. This term in all three equations is right. Yeah. Yes, sir. This term is same. What is changing? In the denominator, in the first equation 1 is present, in the second equation 3 is present, in the third equation 5 is present. So in the first equation 1 is present, that's why I am calling this first harmonic. Okay. In the second equation, number 3 is present, that's why I am calling this third harmonic. Oh, now I got it. And in the third equation, number 5 is present, that's why I'm calling this fifth harmonic. Okay. Okay. So understood the harmonic part, and I also called this the fundamental mode. Fundamental mode. And you understand why this is called the fundamental, because this is the minimum possible frequency by which the string wave can form if the string is fixed at one end and open at the other. Great. And one more terminology we use to define these frequencies, and those terminology will also you will understand. Third harmonic is known as the first overtone. First overtone. Fifth harmonic is known as the second overtone. And this first harmonic can be known as the zeroth overtone. Okay. Now let's understand. Okay, you will understand why these are calling the first zeroth, first and second overtone. Now I want to write the equation for the nth harmonic. So if I want to write the frequency for the nth harmonic, then I have to write it 2n plus 1 divided by 4l root t upon. See, if I will put n is equal to 0, what will be the value of 2n plus 1? It will be 1. If I will put n is equal to 1, what will be the value of 2n plus 1? 2n plus 1, it will be 3. If I will put n is equal to 2, what will be the value of 2n plus 1? It will be 5. Observe the equation first, second, and third. At n equal to 0, I am getting 1, and at n equal to 1, I am getting 3. That's why third harmonic. At n equal to 2, I am getting 5. That's why fifth harmonic. At n equal to 0, I am getting 1. That's why first harmonic. Okay. So and one more thing. For n is equal to 0, I am getting this equation first. That's why this frequency is known as the zeroth overtone. Getting the point? So value of n is deciding which overtone this will be. This is n is equal to 1. At n is equal to 1, I am getting 2n plus 1 is equal to 3. That's why third harmonic, but n is equal to 1. So first overtone. Similarly, here n is equal to 2 and 2n plus 1 is equal to 5. That's why fifth harmonic, but n is equal to 2. Then that's why second overtone. So from this, we have observed a pattern that number 2n plus 1, I am writing it with a different color. Number 2n plus 1 is defining the harmonic term. Okay. Whatever the number 2n plus 1 may be, it will be that harmonic. It is first. If the number 2n plus 1 is first, then it will be first harmonic. If the number 2n plus 1 is 3, it will be third harmonic. If the number 2n plus 1 is 7, then it is a seventh harmonic. And obviously, if it is 2n plus 1, then it will give only the odd value. Okay, it will never give you the even values. And n is given the overtone. Overtone. Okay, so if you will remember this formula, and this is 2n plus 1, f 2n plus 1 is equal to 2n plus 1 upon 4l t upon mu. If you will remember this formula and this thing, then you will completely understand that which harmonic is this and which overtone is this. So I am writing this formula in the bracket. F2n plus 1 is equal to 2n plus 1 upon 4l root t upon mu, where 2n plus 1 harmonic and n nth over n nth over. Great. So just remember this, what is in the bracket, and you will understand. And one more thing I want to point out here.